So category 1, these are kind of the key concepts from category 1. We need to factor, we need to do our laws of exponents, we need to add and subtract polynomials, work with radical expressions, sequences, and literal equations. There's a lot going on category 1. So let's just I'm just going to do a brief recap. First off, I want to remind you when you factor something. So let me put an equation up here to factor. Okay, so this is not factoring, but this is kind of the backwards way of thinking about what factoring is. So when we factor, it's taking our two binomials that we've multiplied. Remember, to multiply, you multiply the first two terms, and then we multiplied the second terms, and then we went underneath and we did them this way. Or a lot of us, in fact, I think most everyone in algebra this year did it with the box. And when we did the box, we said, okay, we put x and 1 out here, and up here we put 2x and -3. And then after that, we multiplied. And so we said 2x times x gives me 2x squared. X times -3 would give me -3x. And then we said 1 times -3 would be over here, and 2x times 1 gives me 2x. And then we said, okay, always on the diagonal, they added together. So this equals 2x squared, -3x, and 2x, when I add those together, give me -1x minus 3. What factoring is when you start with this side and try and get back to what you started with. So some of us used our graphing calculators, and we would graph it, and we would find the zeros. So let me grab my calculator real quick and grab those zeros. Okay, so some of us did this. We would look and we would graph it on our calculator, and we would see that it's at -10 and 1.50. So -1 and 1.5. And it looks something like this. And we would say, okay, well, if we were to factor it, we would put x and x, and we would take the opposite. X is lie. It says it's -1, I'm going to plug in +1. It says it's positive 1.5, I'm going to plug in negative. But remember, we can't put decimals. So 1.5 is the same thing as 3/2. So we would put 3/2 in here. And then we would say x plus 1. We can't leave a fraction, so we took the 2 and we just slid it up right here and said 2x minus 3. We always double checked. X times 2x is 2x squared. So here's my factored form. Now, that was just one option. Another option was to take this, make a box, and put what we know inside here. So we know 2x squared goes here, and we know that -3 goes here. We have to figure out what goes here. So we make a rainbow, and we do 2 times -3 gives me -6. And then we would list out every factor of -6. So 1 times 6 and 2 times 3. Which of these can I put together to get -1? Well, -1 probably going to have to go here. -3 plus 2, that would give me -1. And multiply -3 times 2 is -6. So we take these numbers and we put them in here. This would be -3x and a positive 2x. And it doesn't matter where you put them, you just throw them in there. And then we look. We only look at the top. What do these have in common? Only thing they have in common is x. Once you get that, the rest is easy. X times what would give me 2x squared? Okay, I need a 2x. X times what would give me -3x? Well, I need a -3. 2x times what would give me 2x? 1. And 1 times -3 gives me -3. So here are my factors. X plus 1 times 2x minus 3. And you can look and see all of them match, including the ones that we originally started with. They're all the same. Lots of different ways to do that. All right, let's go to the next topic. So adding and subtracting polynomials. So remember, if I have 3x squared minus 2x plus 1, typically you'll see polynomials in parentheses, and I subtract, we'll say 2x squared plus 6x minus 10. Remember, when you subtract them, we have to remember that if we're subtracting, we have to change it to addition. So we change the sign. And when we change this to addition, we have to change everybody's sign inside here. So negative 2x squared I'm going to put right underneath the 3. Negative 6x I'm going to put right underneath the x. And plus 10 is going to go here. 3 minus 2 would be 1x squared. Negative 2 and negative 6 would give me negative 8x. 10 and 1 would give me 11. So when you subtract those two polynomials, that's what you get for your answer. All right. The other one is we had sequences. So let me put a sequence up here. So here's my sequence. Questions that you're going to have, is this arithmetic or geometric? Well, arithmetic is when you're adding or subtracting something. Geometric is when you're multiplying. Arithmetic is pretty steady. Geometric gets really, really big, really, really fast. So this one would be arithmetic. We had things like the first term, and we had things like the nth term. A sub 1 is always the first term, so it's negative 5. We had things like D, which represented the common difference. What is this doing? These are getting bigger by 3. So here was how you found the nth term. You took A sub 1 and you added the common difference times n minus 1. Okay? So I'm going to show you a couple of ways to do this. The first way is we're going to take it, we're going to put the first term, which is negative 5, plus the common difference times n minus 1. Easy to do there. Here's my formula. Could I find the nth term? Yeah, if I wanted to find the 100th term, I could do it. Another way to do this is to remember that when you're working with a sequence, they always start with the first term. Then there's the second term, the third term, the fourth term, and the fifth term, and so on. I could make a table out of this called the top x and the bottom y. I could go to my calculator and I could do a regression. It would be linear. Now I couldn't do it with geometric, it wouldn't work for that, but I can do it with the linear one. I'm going to do stat, edit, and oh, I've got something in here already. Let me move all that out. Clear all that out. I could put that in as 1, 2, 3, 4, 5, and on the other side, negative 5, negative 2, 1. Okay, stat, calculate, linear is number 4. It gives me y equals ab to the x power. ab to the x power. mx plus b. I'll get it right there. So mx, which in this case m is 3, minus 8. So you're like, but those don't even match, Mrs. Dean. They're not even the same. Well, real quick, if I were to take this one right here and simplify it, negative 5 plus, I'm going to distribute 3 times n is 3n, and 3 times negative 1 is negative 3. Okay? Negative 5 and negative 3, I'm going to have 3n negative, I'm going to put these two together, that'll give me negative 8. 3n minus 8 is the simplified version. Look at that. They're the same. One has an n and one has an x, but they're the same. So you can do your geometric or your arithmetic sequences on your calculator. Just remember they always start with a 1, the first term, and they go from there. Don't start at 0. They always start at 1. All right, let's look at the next topic in here, which I believe is laws of exponents. Laws of exponents. So you're going to have a cheat sheet on your star that you can use. Just remember, when you multiply, it's like texting. You don't want to say, oh, that's x times x times x. You want to shorten it. It's not 3 x's. You're multiplying, so you're counting. All of these are to the first power. How many x's are there? There are 3. Okay? If I have 2x times 3x cubed, okay, you're multiplying first and foremost. So 2 times 3 is 6. On the x's, you don't want to write x and then x cubed. You want to shorten it. So this is 1x here, and this is 3 x's. That's what x to the third means. So I have a total of 4 x's. Now, keep that in mind as we work this. Let's say 12x to the 6th divided by 2x squared. Before you do anything, just expand it out. That is 12 and 6 x's. 1, 2, 3, 4, 5, 6 x's. And on the bottom, it's a 2 with 2 x's. Everywhere they line up, they cross out. 12 divided by, don't even think about your exponents yet. Do your division first. 12 divided by 2 is 6. 1, 2, 3, 4 x's left, and they're on the top. So I'm going to put 4 x's on the top. Okay. Let's see. We also had powers to a power. So if I have 2x cubed, and I'm going to raise that to, we'll say, the second power. What that means, everything inside here 2 times. So this means I take 2x to the third, and I need to do it 2 times, times 2x to the third. This whole thing 2 times. Okay, well, 2 multiplied to 2 is 4. 3 x's here and 3 x's there. How many x's is that total? That is 6 total. For exponents and the laws of exponents, the easiest way is to expand it out. Write out what you have. All right, we had one other one that we did a lot of. Let's take one like this, and let's raise it to the 1/2 power. Okay. Now, remember this exponent, it's hard to say, well, how do I do half of this? Well, I need to expand it out and say 144 to the 1/2 power times x to the 6th, and I'm going to raise it to the 1/2 power, times y to the 12th, and I'm going to raise it to the 1/2 power. So 144 to the 1/2 power, remember your calculator will do that. 144 house top, 1 divided by 2. It's going to do that for you. That's really just the square root, but even if you don't remember that, you can put those 1/2s right into your calculator. X to the 6th to the 1/2, remember that is multiplying. A power to a power is multiplying. So half of 6 is 3. Half of 12 is 6. There's my answer. So radical expressions, remember, they just kind of work the same. Let's see, literal equations. So literal equations are when you have something like this. 5x plus 3y equals 9. A literal equation is when you solve an equation, but you're not really getting an answer. It's just a literal. It's going to have words. When you're solving for y, you move the x, and you divide the y. So that'll be 3y equals negative 5x plus 9. I would divide everything by 3 and end up with y equals negative 5 over 3x plus 3. That's a literal equation. Another literal equation is when you have something like area equals 1/2 base times height, and they say solve this for h. So let me rewrite it. I would say, well, that's the same thing as BH over 2. Base times height divided by 2. If I'm solving for h, I'm not going to move it. This is division. To undo division, I'm going to multiply both sides by 2. And that way those 2's cancel out. Over here, I end up with 2 times a. I still have BH. This is multiplying. To get rid of or undo multiplication, I would divide both sides by b. And that way the b's would cancel out. So my answer would be h equals 2a over b. That is literal. Take your time with it. Okay, I hope that's a great recap of this category 1. Good luck working the rest of them.